Good morning. Welcome to geometry class. From this week lesson, circles in the coordinate plane from 12-5 textbook pages 798 to 801. Before we start, I want you to prepare the following: your geometry textbook, your pen, and your copybook.
What is a circle? When you were younger, you probably learned that anything shaped like this was called a circle. Then you might have seen circles when you took geometry. But what is a circle? Let's go ahead and look at a more formalized definition of a circle. A circle is the set of all points that are a fixed distance r away from a fixed point h, k. So what exactly does that mean? Well, it means we have some fixed point right here. We call it h, k. That's also just the center of our circle. So we have a center located at h, k. Next, we want the set of all points that are an equal distance away from this center. In other words, we're talking about the radius of the circle. If we go out r units, we'll land on our circle. So this r is called the radius. And we can go out r in every direction, and we'll end up with a circle. Let's go ahead and look at a circle in the coordinate plane. So let's take a look at the graph of this circle here, and let's apply our definition of circle. We have some fixed point called the center of our circle. This point is h, k. Now, in this instance, the center of this circle is located at 5, 5. That means our h, k is 5, 5. Now, we can go at a distance of r in any direction, and that will make our circle. So if we go up to the outer edge of our circle, this distance here is r, the radius of our circle. Well, we go from 5 up to 9, so the radius of this circle is 4. Now we can go out 4 in any direction. We could go out 4 this way, or this way, or this way, or this way, any direction, and the set of all of those points that are 4 units away is our circle. So this is our circle right here. Now, how do we write the equation of this circle? Well, to write the equation of a circle, we can write it in what's called standard form. Standard form for the equation of a circle looks like this. We take x minus the x coordinate of our center, which is h. So x minus h, that quantity squared, plus we take y and we subtract our y coordinate, which is k. And we square that quantity. This is equal to r squared. So this is the equation of a circle written in standard form. Let's go ahead and write the equation of this circle right here. Well, we're going to take x and minus our h value. In this case, h is 5. So x minus 5, that quantity squared, plus y minus our k value, well, k is equal to 5. So y minus 5, quantity squared, and that's equal to r squared. Well, we found our radius to be 4. So this is equal to 4 squared. So this is the equation of our circle that's right here. Now, we could also go ahead and square this 4 and get this equal to 16. Another common thing is to see a circle centered at the origin, right here. So what's the equation of a circle centered at the origin? Well, let's go ahead and figure it out. If we have a circle that's centered at the origin, well, then our center, h, k, is just 0, 0. So, we're going to use the equation of a circle in standard form, and we're going to use the center 0, 0 if the circle is centered at the origin. So we get x minus our h value, which is 0, squared, plus y minus our k value, that quantity squared. Well, our k value is 0, and this is equal to r squared. Well, x minus 0, that's just x. If we square it, we'll get x squared. So we get x squared plus y minus 0 is just y. If we square it, we get y squared. So x squared plus y squared, and this is equal to r squared. So this is the equation of a circle that's centered at the origin. So now we know what a circle is.
In this problem, you will write the equation of a circle. What is the standard equation of the circle with center 5, -2, and radius 7? What do you need to know to write the equation of a circle? You need to know the values of h, k, and r. H is the x-coordinate of the center, k is the y-coordinate of the center, and r is the radius. Use the standard form of an equation of a circle. Substitute 5, -2 for hk and 7 for r. Now simplify. In this problem, you'll use the center and a point on a circle to write the equation of the circle. What is the standard equation of the circle with its center at the point 1, -3, that passes through the point 2, 2? How is this problem different from problem 1? That's the problem where you are given the center and the radius of the circle. In this problem, you don't know the radius r, so the first step is to find r. Step 1. Use the distance formula to find the radius. Substitute the coordinates of the center and the point on the circle. Now simplify. So the radius of the circle is the square root of 26. Step 2. Use the radius and the center to write an equation. Use the standard form of an equation of a circle. Substitute the coordinates of the center. Then substitute the square root of 26 for r. Now simplify. So the equation of this circle is the quantity x minus 1 squared plus the quantity y plus 3 squared equals 26. In this problem, you will graph a circle given its equation. When you make a call on a cell phone, a tower receives and transmits the call. A way to monitor the range of a cell tower system is to use equations of circles. Suppose the equation of quantity x minus 7 squared plus the quantity y plus 2 squared equals 64 represents the position and transmission range of a cell tower. What is the graph that shows the position and range of the tower? What do you know? You know the equation representing the cell tower's position and range. What do you need? You need to draw a graph to represent the equation. So what's your plan? Determine the values of hk and the value of r in the equation. Then draw a graph. Write the original equation of the circle. Now rewrite the equation using the standard equation to find the values of hk and r. Remember, the standard equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared, where the point hk is the circle's center and r is its radius. The center is the point 7, negative 2, and the radius is 8. To graph the circle, place the compass point at the center, 7, negative 2, and draw a circle with radius 8. First, plot the center point, 7, negative 2, then place the compass point at the center. Then open the compass to a radius of 8 and draw the circle. The graph shows a circle with center 7, negative 2, and radius 8.
Thank you for listening. If you have any questions, just send it through Schoology. Have a good day.